Right, welcome to lesson number 2 under algebraic expression, products and difference of squares. Say difference of squares, difference simply means there's a minus sign, and when I say squares, 16 is 4 times 4, it's a perfect square. X to the power 4 is x squared times x squared. Same goes for 9, 3 times 3, y squared, y times y. So whenever we're going to find the products, we're only going to end up with 2 terms in the examples that we do. Sometimes more based on the problem, but we'll go through every variation. Right, so for us to understand when it's difference of squares, we have to know there will be 2 brackets with 2 terms in them, and the 2 terms binomials. Both brackets are the same except the signs are different when dealing with difference of squares. So if you look there, I have 4x squared and 4x squared, 3y and 3y the same. But one is positive and the other one negative, so when I multiply out here, I'm going to end up with difference of squares. Same here, m to the power 3x, m to the power 3x the same, 5 and 5 the same, but one is negative and positive, so when I multiply out, I'm only going to end up with 2 terms. Right, difference of squares. Right, so if you look at our problems, for all our problems, we check there, they're the same. So in short, we only multiply first term with first term and last term with last term. So 4 times 4, x squared times x squared. Positive times negative will always be negative. 3 times 3 and then y times y. So 4 times 4 gives me 16. X squared times x squared, 2 plus 2 gives me x to the power 4. 3 times 3 gives me 9. Y times y, 1 plus 1 gives me y squared. We look at m to the power 3x, m to the power 3x. Again, 5, but one's positive, other one negative. So m3x times m3x simply becomes 3x plus 3x. Negative times positive gives me negative, and then 5 times 5. So 3 plus 3 would give me m6x minus 25. Alright, if we go to the next set. Right, so here in problem number 3, we've just made it a little bit more complex, but again, you see I have 3a and 3a, b and b, but one is positive and negative, therefore I just multiply first term with first term and last term with last term. So 3 times 3 gives me 9, a times a squared. Negative times positive gives me negative, b times b squared. That side I had 9a squared plus b squared. Again, you should see 9a squared and 9a squared the same, b squared and b squared the same. So we're just testing difference of squares twice. So 9 times 9, 81. A squared times a squared, 2 plus 2 gives me a to the power 4. Negative times positive gives me negative. B squared times b squared gives me b to the power 4. Want to make it difficult, we try to hide the difference of 2 squares. So you see there I have x minus 3, x plus 3 at the end with x squared plus 9. So first I'm going to bring that over. So it reads x minus 3, x plus 3, and put x squared plus 9 at the end. Again, you can see x and x the same, 3 and 3 the same, but one is negative and the other one positive. So x times x, x squared. Negative times positive, negative. 3 times 3 gives me 9. X squared plus 9. So now I have x squared and x squared, it's the same. Negative 9 and plus 9, the same. So x squared times x squared, x to the power 4. Negative times positive gives me negative. 9 times 9, 81. Right, so I hope you understand. If you enjoy the video, please like, share and subscribe. The more people we share with, the more people we can help, the better they all perform, the better our country becomes. Right?